Isam Mohammad from Bahrain.
Maher from
Hroub from Khalas.
We are studying civil engineering. Our project is about loads building. To design building, we should understand the loads that affect on the building and classify it to make factor for all loads in the building.
We will classify the load to vertical load and horizontal load.
The vertical load consists of dead load, live load, and snow load. The horizontal load consists of wind load and earthquake load.
Dead load. A dead load is the constant weight of a structure, including the structure itself, along with fixtures intended to be permanent. When structures are designed, the engineers must make dead load calculations to ensure that the structure can support itself. Calculating a dead load can be difficult because the final weight of a structure may not be known until it's completed. Engineers use standardized information and estimates about known building materials to calculate the load as closely as possible. The dead load does not change over the life of the structure. It neither increases nor decreases and does not shift or move over time. By contrast, live loads are flexible and they will change over time.
Live loads refer to loads that do or can change over time, such as people walking around building or movable objects such as portable medical equipment in the hospital. When we want to design structural, the value of the live load depends on the type building. For example, in houses 1.5 kN per meter square, in offices and hospitals and schools 3 kN per meter square, and in workshops and parking 5 kN per meter square.
Snow load. Design snow load for structure is based on the geographic location, exposure to wind, it is thermal and geometry. In most cases, there is less snow on the roof than on the ground.
Wind loads. Wind loads are reduced by the flow of wind around structures, and its magnitude vary in proportion to the distance from base of the structure, peak wind speed, importance factor, side of building, and roof slope.
Earthquake seismic load. Structural design of buildings for seismic loading is concerned with structural safety during major earthquakes, but serviceability and the potential for economic loss are also of concern. Seismic loading requires an understanding of the structural behavior under large inelastic deformation. Behavior under this loading is different from wind and gravity loading, requiring much more detailed analysis. Some structural damage can be expected as a result of design ground motion because the code allows inelastic energy dissipation in the structural system.
The seismic analysis and design of buildings has traditionally focused on reducing the risk of loss of life in the largest expected earthquake. Building codes have based their professions on the historic performance of buildings. These professions are based on the concept that the successful performance of buildings in area of high seismicity depends on a combination of strength, ductility manifested in the details of construction, and the presence of a fully interconnected, balanced, and complete lateral force resisting system.
Finally, structural design requires developing buildings that are strong and flexible enough to handle the dead and live loads.
Engineers must also consider resources of stress like high wind and earthquakes that can also generate load and heat to reduce the structural safety.
Buildings are usually required to exceed estimated capacity to reduce the risk of errors.
Thanks for listening.